Good morning. I'm going to be talking about modern documentation across languages, and the focus is going to be on documentation as a workflow. And we're going to talk about how to document different languages, both programming languages, and also how and when to translate over to different human languages. So we're going to be talking about documentation more as a workflow. Now, of course, we're going to expound on this a lot more, but yeah. Let's get started. A few words about me. I'm Rohit Goswami. I am a doctoral researcher at the University of Iceland under the supervision of Professor Hannes Johnson, and I am funded by RANIS, the Icelandic Research Fund. And I'm super happy to be here talking at SERI. And of course, the slides will be made available to everyone after the talk. They are released under this license, the CC by NC 4. A few words on logistics before we begin. All the contents of the slides and the pictures and images are hosted on GitHub. And for those of you who want to see the source files. And questions are not only welcome, they're encouraged, because one other thing I have to say before we get started is that documentation is not a solved problem. There is no one size fits all, and there is no universally good way. We as a community need to iterate on the concept of documentation a lot more until it becomes firm or a complete product in any sense of the word, right? So why do we need documentation? I mean, we're programmers, we write code. So presumably we also read code, right? And so let's take a look at a code snippet in various forms, okay? And let's see how readable that is. So this is snippet A. And you might be wondering, if you're wondering what language this is, well, we'll get to that. But also, this seems like a very strange program if you're not used to assembly. If you are used to assembly, then you probably recognize that the key segment is here and you understand what this code fragment does. But the bigger question is, if I gave this to you, or if someone gave you assembly and told you to read it and understand it and work with it, you'd probably say, who is writing assembly nowadays and asking other people to read it outside of maybe a course? That's just probably not too many people. So let's move to a different form of the same snippet. Okay, what's going on here? This is clearly more C, C++-like, right? We can clearly see that there's a lot of stuff going on out here, but the key segment is right here, right? If you're wondering what this is, what language this is, well, this is Gimple, the famous internal representation of the GCC compiler. Well, actually, Gimple is used across the entire GCC compilation suite. So Gfortran, Gfortran and all the other front ends to GCC, they all combine down into Gimple. This is called Gimple. But once again, you would argue that I am probably, pulling wool over your eyes or trying to pull a fast one with you guys because it's internal for a reason. No human being is going to be reading this. So let's be more fair. When we talk about reading and writing code, then we're probably thinking about something like this, yeah? And here it is abundantly clear what's going on, yeah? For most of us, this is good enough. But if you've never worked with C++ before, this is not good enough. I could show the slide to you and ask you to run this code, and you might be a little bit lost. And the answer is we need more. So the thing on the right, where we talk about what's going on in this snippet, we're assigning an integer. This is how you run it, right? And crucially, why there is no output. So normally we as programmers, we write the thing on the left and we assume the thing on the right. But really, this is documentation. This is the metadata which is required for other people to work with your code. So let's think about different languages as well, right? I mean, maybe it's a GCC thing, right? I mean, Gimple clearly is not readable. Maybe it has something to do with the compiler. Let's look at a different programming language. Let's look at a different compiler. So Fortran, which is an LLVM-backed, it's not backed by LLVM, but it is a Fortran compiler, which is based on LLVM. It has a nicer intermediate structure. It produces the one on the right, with installation instructions and all of that. And already you can see that the one on the right is maybe it's clearer what's going on out here, right? I mean, it's more readable perhaps, but still the key problem is we write in a programming language which is specified according to a language committee, right? And then it gets compiled, or, you know, as they used to be called, automatically coded, right? And finally, it is run, you know, after linking and loading and all of that jazz, it gets run on the computer. But it's really not meant for humans to read that easily. I mean, when language specifications are made, you know, the English language, for example, is a very flexible language, words of multiple meanings, ambiguities, you know, perhaps now is not the time to get into programming language theory, but yeah, it's not meant for humans. Documentation is, and that's what we're going to be talking about. So assuming we have agreed that you need documentation, it's a good idea to have documentation. How do you start? What's the layout? Well, you can start with some metadata right from the get-go, a README file with basic things, motivation, etc., a license, which is very useful. You should definitely add on to everything, and some sort of version control ignore list. If you use git ignore, as I use git exclusively, then it's called .git ignore. If you use Mercurial or Subversion or something, some other version control system, then there will be a similarly named file, right? Okay, but is that a large project? I mean, because one of the things, and sure, you know, that project layout works. It works when you're writing in one language. It works when maybe you're doing a small research project, but what about a large project? Now, it's not fair to just say a large project, right? We need to define it. So especially coming from computational chemistry, this is a problem which we see a lot, that you write an algorithm, you write a library, you write software. So you have a core, and then you have bindings for other languages, because come tomorrow, someone is going to say, I don't know language X, which you programmed in, but I know language Y. Can I use your code? And so you build bindings. And when you do this, you need API level documentation, but also user documentation. And that's what we're going to talk about. So our sample of a large project is going to be SimEngine, which is used for doing symbolic algebra. And it's fantastic. It has a C++ core, and these are its bindings in Fortran, Haskell, Julia, Python, R, Ruby, and other projects, which like, so the feedstocks are for Conda Forge, and yeah, so this is a large project under our definition, right? So how do you normally get documentation? Well, once again, a loaded question. It depends on where or how you're working. So maybe if you've SSH'd into a machine recently or ever, or just seen a terminal, then perhaps you have tried man, right? I mean, if you run a command, you don't know what it does, you don't remember the syntax, the first thing you reach for is a man page. You do man ls, for example, and you get the man page, which is really good for terminal programs. It's very helpful, but it doesn't really help you modify the code or work with it in, like, man pages can be difficult to navigate in spite of the nice syntax highlighting and everything. And they're also not a lot of fun to write, to be totally honest. So what comes next? Well, a book, you know, user manual, something you can just print out and carry around with you. The problem there is that it will get a little out of hand. So the latest C++ standard is, I think it's light 1800 pages. The Fortran run is around 600 pages. But yeah, I mean, and this is the draft. It's a working draft. It's not even a complete one. So maybe not the best approach then. Yeah, I mean, they can be hard to work with. Now, if you're wondering why it took so long to get to websites, well, you know, the truth is, it's nowadays, if you need to look something up, you're not probably going to go to the library. You're probably going to go online and look someone up, right? I mean, I know I looked up a lot of my fellow speakers at SERI, and maybe some of you did the same. And so here's the thing. What do you put on a website? Do you do the documentation? Do you do the user aspect? Do you do the community building? And sadly, the answer is you have to do it all. As an example, I have the Chapel Parallel Programming Language. They have a fantastic question-oriented website, which is really helpful to get into the language, right? They have these various facets. Okay, so in this workflow where you as a human being are writing code based on a standard, right? That's the covenant between you and the machine, etc. Where in this entire process, from writing code to typing it out onto a machine to compiling it, lowering it progressively from C++ to GIMP to or whatever internal representation and all of that, where do you insert documentation? And so we will discuss insertions at the API level, at the tutorial level, and at the contribution level, right? Because these are the main points where you want to add documentation. So from a user point of view, you want tutorials, you want to code along, you want to use the software, right? And from a developer perspective, you want to see the internal workings and you want to have code contribution guidelines you want to give back. So one thing which I cannot stress enough, if you take nothing else out of this talk, always use the right tool for the job, okay? When it comes to programming languages, think about syntax highlighting or font locking if you're from the Emacs side. How do you do font locking or syntax highlighting? What is the basic concept? You need to have an understanding of the keywords of your programming language, right? Similarly, the tool which you are going to use to write documentation needs to have an understanding of the language. And this is why there is no silver bullet. There is no one size fits all. You need to use a tool tailored to the language. And this is not a limitation. So if you're using R, then you need to reach for package down. If you're using Python, you need to reach for Sphinx. For C++, it's still Doxygen, even though we'll see some other examples. And for Julia, there's a fantastic documenter.jl. And finally, for tutorials nowadays, you probably want to use a notebook. And you may not want to write a notebook in notebook format, because if you've ever catted or just looked inside a notebook file, it is a blob of JSON, and you probably don't want to be writing that. So you'd want to use GPText. Okay, so this is how package down looks. This is how documenter looks. And there's really not, this is a Sphinx team, which I'm fairly partial to, called library. A couple of things that you might see is that it does seem to have like source and the documentation. So this is the doc string, right? And here is the source code. So this linking is there across all of these documentation tools, okay? For generic projects, Sphinx is reasonably good, but you should really be using the right tool for the right job. And in user documentation, the right tool is generally a static website, a static site generator, an SSG. As an example, consider DScenes, which has a wiki made with MakeDocs. And because the wiki needs to have a lot more, the wiki needs to have things like a software quality management plan and maybe some contributing guidelines and all of these things, right? We're going to look at C++ a little bit of depth, just a bit, okay? So as a concrete example of doing documentation. So when we go to project files, right, every project file should ideally have, okay, first of all, this is a Doxygen comment, and it should be at the top of every one of your files. If you've used Doxygen before, then you'll know that Doxygen allows two separate styles for writing your code. And in fact, this is one of the problems, that you need a whole style guide for your documentation as well. Now, I personally prefer the Java doc style, which is why you see the @ symbol everywhere. You may or may not have encountered this if you've written Java. But the idea is that the project file needs to have the date it was created and a little brief intro about the file, right? For headers, okay, we will make a distinction between what goes in the header and what goes in the CPP, the source file, right? And the reason is headers get installed, headers get copied onto the user's system, typically in maybe user include. Because of this, you don't want to bulk your header files up too much. You want to keep them slim. So just a quick tip, C++ is of course famously statically typed, so you don't actually need to mention anything about what type or what it is going to return in that sense, but you do need to give an explanation briefly, right? In the source, you're free to add more details about the algorithm and some examples, maybe even a note or two. A word about Inline comments. So inline comments don't go into your documentation typically. If you're writing a single line comment, then it should be describing the algorithm internal workings, the algorithm's internal workings, because it's sort of like describing the flow of the process. Whereas the overview, the bird's eye view, goes in the doc string up here. Okay. So basic Doxygen, I mentioned we covered this very briefly. Basic Doxygen looks like this. It is not mobile friendly. If you don't believe me, try going to the Eigen website and checking out the API documentation on your phone. And depending on your taste, you might find it a little ugly as well. There are lots of projects to get CPP code into Python, into Sphinx. Exhale is one of them. And Exhale is actually quite nice. The only problem is it can't actually include your source code, which is a rather major limitation in API documentation. DoxyRest is another front end, which converts down to Sphinx at the end of the day. It's a little bit complicated and it does have more structure, but it's quite a bit complicated and it's not as automatically linked as Doxygen. Doxygen has almost an entire C++ parser out there. They know what they're doing when they see C++ code. And so what you may want to do is write a theme for Doxygen, which is slightly complicated, but the results are quite nice. I mean, I wrote one called Doxy Yoda and it is mobile friendly and fairly nice. Okay, moving forward. What about translations? And I know I'm reaching the end, so I will speed up a bit. What about translations? Well, you should only do translations at the user level. Don't do them at the API level. For one thing, not all source code will accept all kinds of characters, right? I mean, if you're writing in a different language, then you might have character issues inside your source code. So don't do it, do it at the user wiki level. And once again, right tool, right job, right? In this case, the right tool is Docusaurus because I recently looked into this and yeah, this is an example of, it allows you to have a shadow structure in one language and then a similar structure in the other language, which is fantastic. And you can switch between them. What about reviewing? Now, remember, when we talk about code review, then we're typically thinking tests, unit tests, continuous integration, right? But you can't really do that with documentation. And why is this a problem? Well, consider the following function. It adds two numbers. It's called sum. It's fantastic. There's even a doc string. There's just one problem. It's clearly lying to us. It is clearly doing a multiplication. So now if we had something like a doc test, then, we could test that this is not false, but sadly, most languages don't have doc tests except Junior. So what we want to do instead, and what we can do, is invalidate our documentation. We can have, there's a Sphinx extension for almost anything nowadays. By the way, this is a Jupyter Notebook example from SimEngine. And there is an extension to Sphinx, which allows you to perform a review of a tutorial file or any file, and then it will expire after a particular amount of time. And this is fantastic, and you should do this. So wrapping up in the last 2 minutes. I had to omit a lot of things. I did not go into a lot of detail about the frameworks and SSGs and any of these things. I was unable to cover a lot of continuous integration, and benchmarking is a whole other ballgame. It is very difficult to benchmark code and present fair comparisons, mostly because it depends on so much. Your compiler, how many nodes did you run it on, how many processors you have. It is not an easy problem to look into. And code review, how does this work for you as a team, was also something I was not able to look at over the course of this short presentation. There are further resources where I go into a lot more detail about these, and DSeams is a fantastic example which has all the things which I've mentioned, and SimEngine does as well. I was sponsored for the Google season of docs for working on SimEngine. Now, what should you take away from this? What are the key takeaways? You document at every level, use the best tools for the job, but only internationalize at the user level. I cannot emphasize this enough. And you have to expire your documentation or get another pair of eyes on them because they can quickly go wrong. And also you want to keep provenance, and you need a style guide. You must have one. And if you're not linting yet, then you really should. Linting, having a formatting guide, these are standard practices which you should definitely be using. And that's it. Thank you for your time and attention. Thanks so much.